Let us understand how to draw pressure, volume and temperature entropy diagram for an Otto cycle. So first, process 0 to 1. So it is for the suction. So on the PV diagram we will show this process from the point 0 up to the point 1. So this is the suction of this air. So here I will mark point 0 and this is the point 1. Next is process 1 to 2. So this is the isentropic compression process. So air is getting compressed. So how to show that? So for that we will first find out what is the effect of the compression on these parameters: pressure, volume, temperature and entropy. So this process is isentropic, that means entropy remains constant. So we have to show here S is equal to constant. Now what is the effect of compression on pressure and volume? So we know that because of the compression process, volume decreases and pressure increases. So we have to show here increase in pressure and decrease in volume. So we know that these two parameters are always opposite to each other. Now what is the effect of compression on temperature? So because of the compression, pressure increases, and due to the increase in pressure, temperature will also increase. So we have to show here increase in temperature. Now first we will show the PV diagram. So pressure increase, volume decreases. So here is the volume. So we have to show decrease in volume. So I will select this point, and increase in pressure. So we have to, this is the point 1 pressure. So we have to show increase in pressure. So I will show here the point 2. Now we will connect this point and we will show arrow also. Now we will show process 1 to 2 on the temperature entropy diagram. So we have to show increase in temperature, but this entropy will remain constant. So how to show that? So I will select the point 1 and we have to show entropy remain constant. So we will select the straight vertical line and increase in temperature. So this is the point 1 and here is the point 2. So we will show arrow. Now we will move to the next process 2 to 3. So this is the constant volume process. So here heat addition is taking place at constant volume. So what is the effect of heat addition on this pressure, then volume, temperature, entropy? So first we will write volume will remain constant. So this heat addition is known as the combustion process. So whenever the combustion of the fuel or air is taking place, then what will happen? So we know that when combustion of fuel is taking place, its a temperature will be getting increased. So we have to show here increase in temperature. Then what is the effect on the pressure? So as the temperature increases, pressure will also increase. So this is the important point. Temperature, increase in temperature, increase in pressure, and increase in pressure, increase in temperature. So we will show here increase in pressure. Now what about the entropy? So this is the constant volume process and its pressure is also getting increased. So here the entropy is also getting increased. So we have to show increase in entropy. Now we have to show all this process. So first we will show PV diagram. V constant, P increases. V constant, straight vertical line. So here is the point 3. Then we will show on this TS diagram. So T increases, S also increase. So how to show the S is getting increased? So here is the point 2 entropy. So increase in entropy, we will select the point here, and temperature is also getting increased. So I will show here the new position of this point 3. This is the diagram. Now we will move to the next, isentropic expansion process. So process 3 to 4 is the isentropic expansion, that means entropy will remain constant. So S is equal to constant. Now what is the effect of expansion on pressure and volume? So when the expansion is taking place, volume increases. So V increase. As the volume increases, pressure will decrease. So P decreases. So as the pressure decreases, temperature will also decrease. So we know that the relation between P and T, pressure decreases, temperature also decreases. Now we will show this. So on PV diagram, so pressure, we have to show the decrease in pressure and increase in volume. So 0.3 volume is here. So we have to show here the 0.4. So I will select this point, 0.4, and we will show that is decrease in pressure and increase in volume. Now next we will show on TS diagram. So S is constant and T decreases. So it is important. So T decreases. So I will show here. This is the 0.4 and S will remain constant. So we will write here S1 is equal to S2 and S3 is equal to S4. And here also we have to write V2 is equal to V3. Now next process 4 to 1, constant volume heat rejection. So volume will remain constant. Now what is the effect of heat rejection? So whenever the heat is rejected to the surrounding, then its entropy decreases. So we have to show decrease in entropy. So as the entropy decreases, its pressure will also decrease. So we have to show here decrease in pressure as well as decrease in temperature. So we have to show T also decreases. So whenever the heat is getting rejected, temperature of the medium is getting decreased, pressure also decrease and entropy will also decrease and volume will remain constant. So V is equal to constant. Now we will show this on PV diagram. So decrease in pressure and V constant. So 4 to 1. So we have to draw here straight vertical line. So here volume will remain constant. So V1 is equal to V4 and pressure decreases. Now when to draw this diagram, remember one thing, that this point 2 to 3, that is the P2 and P3 are always greater than this P4 and P1. So for this PV diagram for Otto cycle, we have to take this fact into consideration. And now we will move to the TS diagram. So temperature decreases and entropy also decreases. So if we observe the T4 and this T1, so temperature decreases, that means T4 is higher than T1. So we have to select the point 4 here, and then entropy will also decrease. So here is the entropy at point 4 and this is the entropy at point 1. So we will connect this. Now when to draw this diagram, remember this T4 should be greater than this T1 because here is the decrease in the temperature. Now process 1 to 0. So this is for the exhaust. So 1 to 0 is for exhaust and 0 to 1 we have to show arrow in this direction. 0 to 1 is for suction because the addition of this fuel or the addition of the air in the piston cylinder arrangement, and exhaust means this is getting exhausted, whatever the combustion product are there that are getting exhausted. So it is shown with 1 to 0. So these two processes are opposite to each other. So its effect is getting nullified and we have to consider only this process 1, 2, 3, 4 for the Otto cycle.